Hello everyone, this is Cavell speaking, and today I will be making a video about trigonometric functions, so sine, cosine, and tangent. And I'm going to offer you an alternative to the unit circle, something I've never memorized. But using these few tools and mnemonics and little tricks, they've helped me through college and helped me kind of slip through the cracks and not worry about the unit circle. Okay. So what I do is I memorize two of the right triangles. Okay. There are two very specific right triangles. The very easy one to remember is the 1 square root of 2. Okay. And this just has a 45 degree. Remember, these are all right triangles, so right angle. 45 degrees. And you can also multiply this by x because anything that's a scalable product of this will give you another triangle. Okay. Another one I have is the 1 square root of 3 and 2. So here, for this triangle, I always forget. I always have a hard time distinguishing which one is 30 and which one is 60, right? But one thing you should know is that the bigger the side is, right, the angle opposite of it is going to be bigger. So for example, what that means is I know this is a 30, 60, 90 triangle, right? Therefore, right, the angle that's opposite of square root of 3, the angle here has to be greater than this angle here. So that means this has to be 60 and this has to be 30 degrees, okay? And when you have these two triangles, right, you can find out what cosine of 45 is. You can find out what cosine and sine of 60 and 30 is, right? And more importantly, you can then use coterminals to find the other measurements, okay? And another tool that I use to memorize the value of sines and cosines is, let me show you. It's a little tool that I draw. I would write out the word sine like this, and I would extend the I, okay, and whatever's on the I, it's gonna be 1 and -1, and everything else is gonna be 0, okay? So what does this mean? This means that sine of 0 degrees is 0, sine of 90 degrees is 1, sine of 180 degrees is 0, sine of 270 degrees is -1, and sine of 360 is also 0, okay? So this is 90 degrees. Oh, sorry. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and this is back to 360, which is the same as 0 degrees, okay? And then for cosine, same thing. I'll draw out cos. And for some reason, the cos, the sine and the cos, right, the zeros and the ones are always on the vertical axis, so I know this is 0. Positive 1 on the right and -1 on the left. So what does it say? Cosine of 0 is 1. Cosine of 90 is 0. Cosine of 180 degrees is -1. Cosine of 270 degrees is 0. And cosine of 360 degrees is back to 1. Right, and then obviously you can convert these degrees into radians, right? So this is 0. This is equal to pi over 2. Remember, pi is equal to 180 degrees, right? So this is pi. This is 3 pi over 2. And this is 2 pi. Okay. Or 0. Right? So, is that 3 pi over 2? Let me just double check that. Yes, it is 3 pi over 2. Second guessing myself. So, using these two triangles and the two word kind of diagrams, right? You can find the measurements of all the common sine, cosine, and tangent values that you are usually asked of you on tests and algebra, trig, etc. Right? You definitely won't be getting anything that you can't evaluate with radicals and whatnot, or else they tell you to use a calculator, right? So another tool that I use, right? So let me see if I can delete this. So let me see if I can draw this out. Right, another thing you want to use ASTC. When I learned it, it was all students take calculus, right? Basically says sine, cosine, and tangent are all positive in the first quadrant. In the second quadrant, only sine is positive. Third quadrant, right? Tangent's positive. And for fourth quadrant, right? Cosine is positive. So cosine is only positive in 1 and 4. Sine is positive in 1 and 2. Tangent is positive in 1 and 3. Okay. So one thing you can do is that if you're given some angle, right? Let's just say this is 150 degrees, right? And let's just say you're here to find theta, right? So if you want to find theta, or I don't know, sine of theta, right? Sine of theta, and theta is equal to 30 degrees, right? Then you would think back to the 30, 60, 90 triangle, right? This would be 1, this would be square root of 3, this would be 2, right? And remember, this is going to be 60, and this is going to be 30, right? And if you say sine of 30 degrees, right, you know it's going to be opposite over hypotenuse. So sine of 30 is, so sine of 30, right, is going to be 1 over 2, right? But now, what if it were flipped, right? What if it was sine of, let's see, sine of 210, right? So let's just rewrite this. So sine of 210, right? So 210 is something like this, right? So this is 210 degrees, right? This is 210, right? So that means this here right now is 30 degrees, right? And you can always obviously draw a triangle, right? This would be 1, this will be square root of 3, and this would be 2, right? So you can always draw the 30, 60, 90 triangle, right? So you know that sine of 210, right, degrees is equal to sine of 30 degrees, right? But here's the thing, it's ASTC, right? So sine is only positive in the first and second quadrant, right? So that means for this one, this is basically equal to negative sine of 30 degrees, right? Sine of 30 degrees is opposite over hypotenuse, so this is basically negative 1 over 2. Okay. Obviously, there's a lot of ways to approach these problems, and these are just some of the few tools that you can use to help you out. All right. Thank you for watching. Bye bye.